so it's a disadvantage if you want to detect disease, but it's an advantage if you want to measure heat stress. Yeah? We've done a trial where we put animals in a paddock with trees and without trees. A savanna paddock is without trees, and the open woodland is with trees. And we measured the body temperature of those animals. So we've seen, for example, that temperature is higher in animals that are in paddocks that have no trees. So again, the technology is picking that up, and it's detecting there is an effect of shade on animal physiology, which is good if you want to study animal response to environmental conditions. Then we also detected an effect of breed, particularly with the eye temperature. So we've seen that the animals that are adapted to tropical conditions, which are the Brahman breed, have lower temperature than Bengal red, which is an animal not as adapted to heat stress as the Brahman. And then in addition to that, we've seen also that the age of the animal has an impact on body temperature. And we believe that was because of acclimation, because we moved these animals from the south to the north of Australia where it's hotter, and animals that were older had lower temperature. So we believe that's because they can adapt faster to hot conditions. So again, this is a lot of information, but it aims to highlight what the effect is of different environmental conditions and animal characteristics, animal biology, such as breed, on the body temperature of animals. But in the end, they are factors that we need to consider. Now, with Mohammed, we've been working in a few devices that are collecting data. There is a whole range of technologies that are available, and they have different characteristics. I'm not going to get into that because eventually Mohammed will get into that. But the place that we measure the body temperature also has a big effect, and I think Mohammed is going to cover this as well. But basically, what we use is the temperature of the eye, because it's where we have the blood vessels that are closer to the temperature. Now, the other thing that has to be considered is that every technology or every device will give you a different measurement. So developing an algorithm may also be specific to a particular device, and you eventually may need a different algorithm for different devices. Yeah? So as we can see there, for example, the handheld device, a camera with the iPad sensor or a video camera, they did give you a different temperature, and that temperature is about 2 degrees or 2.5 degrees difference, which is quite large. Now, one of the main things we were working on is on trying to use this technology for disease detection and also to detect animals that are stressed in the abattoir. So what you see there are 2 pieces of meat. The one on the left-hand side is what we call the dark cutter, and the one on the left-hand side is an animal that is a normal meat. And the normal meat is an animal that was not stressed prior to slaughter, and the meat quality is better. The one on the left is lower meat quality and animals that were stressed before being slaughtered. So annually, meat quality due to stress causes a loss of $55 million in Australia. And not only is the loss because those meat with dark cutting meat is paid lower, it's not as good as the other one, but it's also public perception and how people see animals that may be stressed before slaughter. So if we can pick up those animals and detect those animals, then we have animals with better welfare and people consuming more meat. So now, what is the link between body temperature and meat quality and stress? Well, basically, animals store energy in the muscle in the form of glycogen. So that glycogen are like molecules of glucose in a chain, and that's in the muscle. When the animal is stressed, it has to fight against the stress, and for that we'll use the body reserves of energy, particularly the reserves in the muscle. So we'll use that glycogen, and if the animal is stressed too much, it will deplete that glycogen, and therefore that glycogen is not will have lower concentration of glycogen when you kill the animal. And why is linked to meat quality? Because after you kill the animal, there is a process of maturation of the meat. And that process involves enzymatic breakdown of glycogen in the muscle into glucose to lactate, because it's an anaerobic degradation. And that lactate is then what reduces the pH of the meat. So for proper maturation, we need to decrease the pH of the meat from about 6.5 to around 5.5. And if you use that, the animal uses that glycogen before slaughter, then the meat will not mature, and therefore you will get dark cutting. And an animal that is stressed also will have higher temperature, because stress increases heart rate and burning up of energy, such as glucose. And we have done a lot of trials trying to do that, to measure that link between physiology and the response of the animals. So what we see in here is two animals, one that had dark meat and one that had no dark meat, and therefore those animals have different body temperature as well. So you see an animal with 5.77 pH and another one with 5.55. So the big question is whether we can detect animals at risk, and particularly in commercial conditions in abattoirs. So normally to do that, we use blood sampling to measure different indicators of stress in animals. And we can sample also, for example, urine or saliva, measure animal behavior or rectal temperature or heart rate and respiration. But all of these measurements cannot be done in commercial situations at the speed that you need to do it in an abattoir. So one of the things that we are looking at doing now is to detect those that cut in meat, look at the relationship between body temperature and meat color and pH, and then also look at trimmings and bruising of the animals when they have problems in the body, in the muscle injuries, and link that to indicators of stress, such as behavior or blood metabolites. And then with that, develop an automated system for detection and identification of unhealthy or stressed animals. So we've been working in commercial conditions where we have systems set up similar to what you see in the picture. So animals are detected by the electronic ear tag as they walk through different parts of the abattoir or the farm. And we set up cameras where we can measure the temperature of the body of the animal. Yeah. So, and those are the conditions where we set up the system. So this is an example, and Mohammed, I'm sure, will show some more of these. But these are animals in an abattoir, and they are going through the race to be slaughtered. Now, this is also an example of sheep in an abattoir, and what you can see there, for example, I don't know if you can see the crosshair there. So the cameras are automatically detecting those animals that are hot and signaling that to tell you that animal is hot, so you can go and inspect that animal further. And then there is a lot of data processing that I'm not going to cover because Mohammed, I think, is going to cover, but we need to process that data extensively. And what we have found is that there is a relationship between infrared temperature of animals and meat color. So animals with dark meat will have higher temperature before slaughter. And in addition to that, also animals with higher pH in the meat also show higher temperature before you kill them. So we are starting to try to use some of this information for meat grading and, determine whether an animal is apt, it is good quality meat. So what we call pH fail or not. So animals that are a pH fail that have high pH in the meat, they have higher temperature, and that's where we are trying to pick up those animals with lower meat quality. So as a conclusion, I'm not showing all the results in here, but we have done results and they are all published and available in my webpage of the University of Sydney. If you Google my name, you'll see the publications there. But we have found a relationship between body temperature and indicators of stress, such as the concentration of glucose, the concentration of lactate and haptoglobin and creatinine kinase. Creatinine kinase is an interesting one because it's an indicator of muscle breakdown when the animal has to spend too much energy, for example, trying to deal with the stress. And we found that animals that had higher temperature with infrared thermography, they do have higher concentration of creatinine kinase and also have higher concentration of haptoglobin, which is a acute phase protein indicating the animal has been sick or under stress. Now, the other thing is we have found links to poor quality meat, such as meat pH and meat color, marbling, and eating quality. But one of the things that we have to look at is on the results on different conditions. For example, it's not the same to measure the body temperature in one farm than in another farm or under a roof or in the open environment. So all those environmental conditions will affect the measurements, and we need algorithms that can deal with that. And but the important thing is that you know, infrared temperature can detect the stress. However, we looked at, for example, another trial where we simulated different stress levels, and all animals were too stressed, and it didn't pick the difference between different levels of stress. Last slide, it's a little bit of a conclusion that the technology is really good because you can measure the body temperature of animals in very dynamic or fast moving conditions as they go through a race, because you can take up to 1,000 frames per second. However, the technology is very sensitive and will pick up any little effect of environmental conditions, but also anything that can affect the temperature of the animal. But it can be used to detect dark patterns, and with that reduce the economic impact of dark cutting on you know, the economy of farms. And there is a need to continue doing research to develop algorithms that can in a way deal with the effect of environment or correct for the effect of the environmental conditions. And we also need machine vision systems like the one that Mohammed is developing and working on to be able to track animals and to extract the important information from those animals. Thank you very much. And if you have any questions, then I'll be happy to respond to any.
Thank you so much, Dr. Luciano, for this wonderful presentation. We really appreciate your collaboration with AlMaarif University College, and hopefully in the future we will continue as Dr. Muhammad Ahmed Jadou. He is working at the university. He was working at the University of Sydney, and he hoped to back to Australia in the future, and we make a strong collaboration.
I hope so.
So
very good. Well, thank you.
Yeah, really appreciate. So before we move to the Dr. Muhammad lecture, so I'm asking the audience if you have any question to Dr. Luciano. If you have any question, you can open the mic and ask directly Dr. Luciano.
Thank you very much, Mohammed. It's a pleasure to be here, and hopefully we can continue working together. I think I've seen a couple of questions there, whether the technology can be used for other animals. Yes, because that's a general response in animals. And humans, when we get stressed, we increase body temperature because we pump more blood and we burn more fuel to try to deal with stress. So that is a general response across all animals. We burn up glucose and energy, and that produces heat, and that increases body temperature together with increased heart rate. So yeah, the technology will be applicable for all the applications as well, for all the animals and for all the situations. But the algorithms will need to be eventually tailored and corrected for every condition.
So, Dr. Luciano, this is my question actually. Just you mentioned this application can be, for you usually target the cow. I think most of your study and research targeting the cow. So let's say for the chicken farm, will be applicable this application, and is it useful?
Mm-hmm. Yes, well, that's a very good question. I didn't work with poultry, and I didn't apply the technology to poultry, so I cannot comment in that. But there are research that have shown also similar responses, and that can pick up the temperature of the animal by using infrared thermography. Now, one of the things is, the eye of a poultry is much smaller, so eventually we'll need much better definition in the cameras. And we may need much better algorithms as well to detect, very, very small regions with high temperature.
I want to ask something for Dr. Muhammad Ibrahim. I read some papers about using infrared thermography for poultry field, and it is useful. So they're using for the prediction of fishing. And it's really useful also for the same animals. So it is also applicable.
Mm-hmm.
Yeah.
Thank you. Before we move, anyone have question before we move? So Dr. Muhammad, I think there is no question, so you can start.
Okay. I'll do the share screen. Okay, everyone can see the slides?
Yeah, it's clear.
Okay. Before that I start this, I will explain about using the artificial intelligence in animal production, and this part is from my research and PhD degree, and it was under supervision of Dr. Luciano for the animal feed, how to use the artificial intelligence to solve water problem in agriculture. So I will start by the outline. I will start by the introduction, and after that I will speak about the animal production problem, specifically about the dark meat and the current use method in stage 3, the current use method for the solving the dark meat. After that I will speak the challenges with this method, and after that with the proposed methodology and the role of the AI to solving these challenges by the developing automated system, and with the end with the conclusion. So what is the artificial intelligence? Artificial intelligence is the area of computer science where we develop intelligent machines or computers which are capable to work like humans or mimic their behavior. So this is the definition of the artificial intelligence. So what the artificial intelligence has several subfields. It's the start by the machine learning, and apart from the machine learning is the deep learning. Deep learning is involve hundreds of the neural networks. Other fields they're using for the artificial intelligence are also machine learning, natural language processing, and most of use in translation, and has many applications like text generation, question answering, context extraction, classification, machine translation. Other field is the speech recognition. They use for the speech recognition the text to speech and the speech to text, And as example, if you notice, Amazon, they use Alexa for the using the machine learning and the AI to translate and to make it like the device is mimic like a human for the speech.